Permutations and Combinations. A permutation of a set of distinct objects in an ordered arrangement of these objects. We also are interested in ordered arrangements of some of the elements of a set. An ordered arrangement of R elements of a set is called an R permutation. If n is a positive integer and R is an integer with 1 less than or equal to R less than or equal to m, then there are P and R, m times n minus 1 times n minus 2 times n minus R plus 1 are permutations of a set with n distinct elements. Equations on permutations. If n and R integers with 0 less than or equal to R less than or equal to m, then P and R n factorial over n minus R factorial. Whenever n is a non-negative integer, we see that the formula P, n, R, and the factorial n minus R factorial also holds when R is 0. On the practical examples on permutations, in this example, how many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered the contest? In the solution, P, n, and R, and n is factorial over n minus R factorial, 100 minus 100 factorial over 100 minus 3. It's become 100 factorial over 97. Then put 100 times 99 plus times 98 times 97 over 97. 97 will be cancelled. So it's become 970,200. On the second example, P n, 210. Find the value of m. So the solution we can use in the n factorial, m times n minus 1 times n minus 2 over n minus 2. n minus 2 will be cancelled. M times n minus 1 which equals to 10. Multiply with them n square minus n which equals to 10. n square minus n minus 10, 110 which equals to 0. So you need to factorize with them n minus 11 times n plus 10 which equals to 0. n which equals to 11 and n which equals to minus 10. n which equals to 11. Positive integer n only. n is equals to 11 only. And minus 10 doesn't belong to a negative integer. So only the solution will be n equals to 11. Combinations. We now turn our attention to counting unordered selections of objects. We begin by solving a question. An R combination of elements of a set is an unordered selection of R elements from the set. Thus, an R combination is simply a subset of the set with R elements. The number of R combinations of a set with n elements, where n is a non-negative integer and R is an integer with 0 less than R less than n, equals C n, R equals to n factorial over R factorial n minus R factorial. Practical examples on combinations. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from a standard deck of 52 cards? Then 52 factorial over 5 factorial times 52 minus 5. Then 52 factorial over 5 factorial times 47 factorial. It's become C n, 2 is equal to 45. Find the value of n. We can check it like that at the combination of formula. n times n minus 1 times n minus 2 over 2 times n minus 2 which equals to 45. n times n minus 1 over 2 which equals to 45. n times n minus 1 equals to 90. n square minus n which equals to 90. n square minus n minus 90 which equals to 0. n plus 9 times n minus 10 is equals to 0. n which equals to minus 9 and n which equals to 10. So it's become 9 and n which equals to 10.